Hello, I'm Vaibhav, and I was given 2 minutes to introduce myself, but then I thought, why not teach you some maths? I think that's the best way you'll get to know me. So, because we are running out of time, I'll straight get to a question. And no matter which standard you're in, I think you're going to find this question interesting and practical too. Let's see what it says. In a chess tournament with 21 players, every player has to play every other player but exactly once. How many games would be played in this tournament in total? The total number of games played by everybody. There are many ways you can answer this question. You can actually sit down and write all possible games, player 1 with player 7, player 7 with player 19, player 16 with player 21, but that would take you a long time. And even if you did that, you'll be very unsure whether you did count all the games or maybe you overcounted some game, right? How can we be a bit more logical, a bit more mathematical and try to solve this question? I have a question for you. How many games are you going to play? Imagine you're player 1. How many games are you going to play? Not total number of games in the tournament, just how many games would you play? 20, right? Because you're going to play the remaining 20 players. So that's 20 games for you. In fact, whichever player you pick, say I picked player 7, asked him how many games are you going to play? The player 7 would also answer the same. He or she is going to play 20 games. Does it mean that since all the players are going to play 20 games and there are 21 players in total, should the total number of games in this tournament become 20 times 21? 420? Is that the correct answer? It's not actually going to be 420. Why? Because when we multiply 20 times 21, we are actually overcounting the same game more than once. You see, when we counted 20 games played by player 1, we are counting each of the games for the first time, really. But when we counted the games played by player 2, the player 2 also did play 20 games really, but this particular game, player 2 versus player 1, is a game we've already counted. It's a game played by player 1. So the new games to be counted should actually only be 19. Similarly, when you move to player 3, the total number of new games to be counted would not actually be 20, but would rather be 18, because player 3 versus player 1 already counted as a game of player 1, player 3 versus player 2 already counted as a game played by player 2. The remaining games are of course being counted for the first time, and so the new games to be counted in this column would be 18. Do you see a trend here? Player 1, we found 20 games. Player 2, we found 19 new games to be counted. Then we find 18 new games, and this trend is going to continue. In fact, by the time you reach the 21st player, there's no more new games left to be counted. So you realize that these additions, in fact, let me write them down, goes all the way till 0. So if we want to accurately count the total number of games, we must not do simply 20 plus 20 21 times. We should rather do 20 plus 19 plus 18 plus all the way till 1 or 0. It's the same thing, right? That is what I've written here. But how do we make this addition? Well, one way is you use a calculator, but still you'd be unsure because maybe you misclicked, you missed a number, you put a number twice, who knows? Can we still be more mathematical in making such an addition? You see, this addition is actually special. If I start pairing up the extremes, the first term and the last term, it adds up to give 21. 20 plus 1 is 21. If I pair up the second term to the second last term, it still gives me 21. 19 plus 2 is 21. 18 plus 3 is 21. 17 plus 4 would be 21. And so on. So it's great news that whenever we are pairing up the extremes, we are getting exactly the same constant sum, which is 21. But the next obvious question is, how many pairs can we make? Which is actually pretty easy to answer, since we have 20 numbers in total and we are making pairs, first paired with the last, second paired with the second last, and so on. We'll be able to make 10 pairs. So each of those 10 pairs are going to give you a sum of 21. So the total sum must be 21 times 10, which is 210. And 210 is actually the correct answer to this question. Let me write it down. But let me tell you, I have not solved this question in the best possible way. If we make a slight smart tweak to our strategy, we could have solved this question much faster. Over here, when we were counting the total number of games, remember, initially we had realized that every player is going to play 20 games. What if we did really count 20 games for each player? What if we did that and then just decided to do 20 times 21? Now we know that is not the correct answer because we are overcounting. But how much are we actually overcounting? When I simply multiply 20 times 21, the answer that I'll get is exactly double counted. Do you realize that? Pick a game. Let's say player 1 versus player 2. When we did do this 20 times 21, how many times did this particular game get counted? It got counted once as a game played by player 1, and it got counted the second time as a game played by player 2. So this particular game, player 1 versus player 2, is getting counted twice. The same can be said for any other game that you pick. Let's say player 3 versus player 4. It would be one of the 20 games played by player 3. And then again, it would be counted as one of the games played by player 4. So we can say that when we are multiplying 20 with 21, we are counting each game exactly twice. So if we wanted to find the correct answer, we could actually do 20 times 21 and then divide that with 2. Because we know 20 times 21 is an answer which is counted every game 2 times. So let's divide this product with 2 to get the actual answer. And that does give you the correct answer. 20 times 21 is 420. 420 divided by 2 is actually 210. So obviously, I feel this is a more smarter way to solve this question. I took this other addition route to show to you that even addition sometimes can get interesting and you can apply certain tactics to them.